In this video, we're going to talk about the product rule. The product rule is the rule that you would use to take the derivative of the product or multiplication, right, of two functions. So here's the statement of the product rule. If a function h of x is built by multiplying two functions f and g together, then when you take the derivative of h, what you should do is take the derivative of f and multiply by g. That is, don't take the derivative, just multiply by g, then put a plus. So add f. Okay, so you would just rewrite the function f here and then multiply by the derivative of g. So the first thing you probably notice about the product rule is that it is a little bit more complicated than the sum or the difference rule. Right? In the sum or difference rule, if a function is built by adding two functions, then you just add the derivatives to get the derivative of the original. And for the difference rule, it's the same thing. If a function is built from subtracting two functions, well, to take the derivative, you just subtract the derivatives of the individual pieces that you use to build it. But the product rule is just naturally more complicated. So that is the first thing that you're going to have to overcome. Your brain kind of wants it to be the derivative of f times the derivative of g, but it just simply does not work that way. Okay, you can't take the derivative like that, and that will give you incorrect results. So you must use the product rule to take the derivative of the product of two functions. Okay, so that's the statement of the product rule. Let's take a look at a few examples of how this will work. Okay, so in the first example here, we want to take the derivative of this function, x to the 7th times sine of x, right? So that definitely is the product of two functions. I have this function here, x to the 7th, which is a power function, and it is being multiplied by this trigonometric function sine of x here. So this is a situation where we would use the product rule. Okay, so to take the derivative, first thing is we are going to take the derivative of x to the 7th power using the power rule, right? So that's going to be 7x to the 6th. Then the product rule says just rewrite sine x. So just write it down. Then put a plus, right? And then we're going to reverse what we did before. So the first time around we took the derivative of x to the 7th. This time we're just going to rewrite it. Okay. And then we are going to multiply by the derivative of sine x. Sine x we left alone in the first round, so now we are going to multiply by its derivative, and the derivative of sine x is cosine x. A lot of times in these problems, one of the issues is knowing when to stop. There is a lot of simplification that you could do here, or some simplification. You could factor out that x to the 6th right here out of here, and that's not really necessary in this point in the course. Later on in the class, we will be using derivatives to answer other problems, other questions, and in those problems you probably would want to factor out this x to the 6th here. But for right now, we are just taking the derivative of these functions, and the questions on our quiz will be multiple choice questions. So what you should do is to match your answer to the multiple choice answer there, of course. And also when you're working any practice problems, that's a good idea, is if you have the answers, to make sure that your answer matches the answer in the practice problems. For right now, just do any minor simplifications, but there's really no need to go any further here. And in other examples, we'll take a look at some simplifications that you should probably make. All right, here in example 2, I have x cubed times e to the x. We want to find the derivative. So that is a product rule problem, right? I have this function, x cubed, a power function, multiplying by this exponential function, e to the x, right here. Okay, and so we want to use the product rule. So the product rule says take the derivative of x cubed, right? The first function there, that will be 3x squared. And then just rewrite the other function. Don't do anything with it. Just rewrite it, multiplying times the derivative of the first one. Next, put a plus, right? That's what the power rule says. And just rewrite the function that you took the derivative of the first time. So the first time we took the derivative of x cubed, we just are going to leave it alone this time. And then finally, multiply by the derivative of e to the x. The derivative of e to the x is e to the x again. So sometimes that looks a little confusing. It kind of seems like, well, I didn't do anything, I just rewrote it. But remember, the derivative of e to the x is e to the x. It's its own derivative. So even though it might not look like we did anything here, at this point we took the derivative. It just happened that it was the same as the function itself. Again, here there's a lot of stuff that I could factor out. I could factor out an x squared here and an e to the x. It's not really necessary that you do that. Like I said, just kind of match your answers to the answers on the quizzes or homework problems. On the exam, where it's sort of free response questions, then I'll be pretty explicit about the directions that I want you to do. Either I'll say something like simplify as much as possible, and in which case I would expect you to carry out a lot of the simplifications, or else I will say don't simplify at all, just take the derivative and don't do any of the simplifications. On the problems where I really don't care if I want you to simplify or not, I just won't put anything there. Although, you know, if you had something like 5 times 3 here, I would expect that you would multiply that out to get 15 or reduce any fractions that you had there. But if I don't give you explicit directions on the exam about how to simplify it, just make the minor simplifications and leave it at that. All right, the next example, we have f of x equals the square root of x times the natural log of x, and we want to find the derivative. So again, this is a product rule. Here I have the square root function being multiplied times the natural log function. Right? Before you do anything, probably what you would want to do is to rewrite that square root function in the fractional exponent notation, right? Because then that means that we can more easily use the power rule to take this function's derivative. All right. So here we're going to start with the power rule on x to the 1/2. So we're taking the derivative of x to the 1/2. We would bring the 1/2 down, right, and then subtract 1 from the exponent. So 1/2 minus 1 will give me a negative 1/2. So the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Next up, we would leave ln x alone, right? Then put a plus, right, according to the product rule. And now then on the second half of the product rule, we would just leave x to the 1/2 alone. We wouldn't do anything with it. Just rewrite it. And then we would multiply by the derivative of ln x, which is just 1 over x. So here, there is some definite simplification that we could do, right? Over here we have x to the 1/2 times 1 over x. In effect, we are taking x to the 1/2 and dividing it by x, right? And so we are dividing like bases, and so we would subtract the exponents. So over here, the only thing that changed is over here from this step to this step, we have x to the 1/2 minus x to the minus 1 here because we're dividing by x. So 1/2 minus 1 gives me a negative 1/2 right here. So I'm just reducing that, and I would expect you to do that kind of simplification no matter what. Don't leave it as x to the 1/2 over x, right? Reduce that down to x to the minus 1/2. So on this one, there is a lot of simplification to do that you can do. Not totally necessary that you do that. Again, on the exams, I will be specific, but on this one, I just kind of want to go over how you can simplify this because you can make this look a lot nicer. So one thing that you can do, right, because these things have negative exponents, is that you can put these down in the bottom part of the fraction there. So this x to the minus 1/2 can come down here with the 2, right? X to the minus 1/2 is the same as 1 over x to the 1/2 power. All right, next up, then I can take this ln x and put it up here in this fraction. And then what I'm going to do is combine these two fractions here. You can see that x to the 1/2 times 2 over here, that's pretty close to x to the 1/2. So it wouldn't really be that difficult to get a common denominator. To get a common denominator, what I would do is multiply top and bottom of this fraction to get 2x to the 1/2 on the bottom. So that would match this denominator exactly. So multiplying the 2 here and the 2 here, I get this. And now these two fractions have a common denominator. Okay? And so I can add the numerators and keep the same denominator. So if you simplified this down completely, you would get this form right here. And later on, when we go to use these derivatives to answer other questions, then we will want to write our answers, if possible, as a big fraction like this, if that's how the function appears. So this form is just going to be a lot more useful later on than the other form that we had it in. It's just a lot easier to analyze this function like that. Having said that, for right now, we are just practicing taking the derivatives. So again, don't worry too much about it. On the quizzes and homework problems, just match your answer to the answers that are there for multiple choice, or if it's a homework problem, to the answer of the homework problem. On the exam, again, I will be explicit on those problems where there's a big question about whether or how you should put your form. So, all right, one more example here. Let's take a look at this function. If f of x equals 4 times x squared plus 3 times the inverse tan of x, find the derivative. So on this one, again, it's the product of two functions. And in fact, you might say, well, look, there's 3 functions being multiplied here. And that's true, right? But this one is a constant, okay? It's just a number. So we know that we have the constant multiple rule. So you could kind of treat this 2 ways. You could put the 4 with the x squared plus 3 and do the product rule. And that's how I'm going to do it. Otherwise, you could use the constant multiple rule and then say, just rewrite the constant 4 and then use the product rule on these last 2. On these last 2, you must use the product rule, right? Because this factor right here is not a constant. It has an x in it. So it's not just a number. So, like I said, I'm going to treat this as 1 unit when I do it, the product rule. And so let's go ahead and do that. All right, so to use the product rule, what I'm going to do is first take the derivative of this part right here, 4 times x squared plus 3. All right, so I have a constant 4 times x squared plus 3. The constant multiple rule says just rewrite the constant, which is what I did right here, and then multiply by the derivative of the function part of it. Well, the function part here is a sum of 2 functions, right? And so using the sum rule, I would take the derivative of x squared, that's 2x, and then add the derivative of 3, which is just 0. So the derivative of 4 times the quantity x squared plus 3 is 4 times 2x. Then going back to the product rule, right, I would rewrite I would just write down tan inverse. Okay, so that's the first half of the product rule. Then the product rule says put a plus, right? And then the function, or the part that you took the derivative of in the first round, just rewrite it. So in the first go round, I took the derivative of 4 times x squared plus 3. So I'm just going to rewrite it here. Okay, and then I am going to take the derivative of tan inverse, right? And the derivative of tan inverse is 1 over 1 plus x squared. Okay, and so that's what I get here. On here, there's some minor simplifications that you could do. Definitely, right, you would need to multiply this 8, the 4 times the 2x to get an 8x out in front. So I would just expect that you automatically would do that part of it here. Right, that's just naturally simpler than writing it as 4 times 2x. Over here, I wrote all of this as one big fraction. That part's not totally required, nor is it required that you write this 4 or distribute this 4 through the parentheses like that. That's just as good as this. So if you didn't do that part or distribute the 4 through, I wouldn't really worry about that. All right, and so that's it for the examples on the product rule.